Hello champions, I am Chandan Biswas, and in this video we are going to learn about emission spectrum of hydrogen, also known as the line spectrum of hydrogen. This spectrum are observed when any hydrogen gas is taken in discharge tube and we pass electric current through it, and due to which the gas glows, and this radiation of the glowing is diffracted using a prism, as you can see. This prism then splits the given radiation into different parts, and these parts form a pattern looks like that, and therefore this is called the emission spectrum of hydrogen. The reason for this spectrum is considered to be the excitation of hydrogen atoms. The electrons in hydrogen atom, they get excited by the electrical energy which is given to it, and due to this excitation what happens is that electrons will go to the higher level of energy, and when they got de-excited, which means the electron comes back to its ground state, as a result the high energy to low energy transition leads to a release of light waves, or basically energy waves. So these energies are basically nothing but coming out as a spectrum. So this is the basics of emission spectrum. Now the energy of any photon which is released during this spectrum is given as this formula. As you can see, the wavelength is taken as lambda, so the lambda will be written as 1 by lambda equals RH. RH is called the Rydberg's constant into Z square. Z is the atomic number, into 1 by N1 square minus 1 by N2 square, where N1 is the final energy level and N2 is the initial energy level. So as we can see that whenever any transition happens, this equation forms, and we have to just put the value of N1 and N2 in order to get the wavelength of such a transition, or the photon which we are talking about. So this equation itself is known as the Rydberg equation, and this Rydberg equation is very important because it also has a constant known as RH. The value of RH is taken in two different ways. In this context, since we are calculating the wavelength has to be taken as RH equal to 109677 centimeter inverse. So this is the constant which you are using. So lambda here is wavelength, R is the Rydberg's constant, Z is the atomic number, N1 and N2 are the final and initial energy levels respectively. Based on this formula, we have a different series of different transitions. For example, we have 5 different series: the Lyman series, Balmer series, Paschen series, bracket series, and Fund series. So Lyman series is the series of spectrum which occurs when any electron gets transitioned from any higher energy level to n equal to 1. Similarly, Balmer series will lead to any spectrum caused by the transition of any higher energy level to n equal to 2. Similarly, Paschen is caused when any high energy level gets transitioned from n equal to n equal to 3, and bracket is from any higher energy level to n equal to 4, and finally Fund is basically the any high energy level to 5th energy level transition. So when we put these values of n in the respective Rydberg's formula, we get different kind of equations, as you can see: Lyman, Balmer, Paschen, Fund, and bracket. Right, so these are the spectrum of the hydrogen. Now there are certain formula attached to it. If I ask you what is the number of possible spectral lines or the line spectrum found when any electron gets transitioned from N2 to N1. So how do we do it? The difference is taken as delta n. Delta n can be written as N2 minus N1, and this difference we can write here. The number of spectral lines formula is taken as delta n into delta n plus 1 upon 2, where delta n is the difference in the two energy levels. Talking about the first line and the last line, as we can see here, the first line of Lyman series can be taken in the first starting series, which is basically 2 to 1 will be called the first line of Lyman series, and the last line of Balmer series will be from infinity to 1. So we are going from first line, second line, third line to the last line, like that. Similarly, if we talk about Balmer series, the first line will be the transition from n equal to 3 to n equal to 2, and as we can easily guess, the last line will be from n equal to infinity to n equal to 2. Similarly, we can frame all of these patterns for different series. The 5 series which we talked about, these 5 series are very important as per the competitive exams are being asked. So that's all about the line spectrum of hydrogen. I'll see you in the next one.